Good morning. Okay, so this is 3.1 chain rule, calculus 1. We're going to differentiate a composite function, differentiate a to the x, where a is greater than 1 and a is not equal to 1. All right, so and use chain rule for all these. All right, so let's first talk about chain rule. So the way that you're going to see it, and the way that's probably going to get you the most, because there's always one of these on the AP exam on the free responses, something that goes along with this. You have to understand that when you have a chain rule, so you're going to have to do some things like this. So it's the derivative of the inside, right? So this is when I have one thing inside the other. It's the derivative of the inside times the derivative of the outside without changing right here. So I don't change g. I don't change that one. That one's not the derivative, that one's just the function. Okay? So you're going to reference this thing several times. Okay? You're going to keep coming back to this. So for right here, what is the derivative of the outside? So let's treat all of this right here like that is the u. If I call that u, I say u is x3 minus 4x plus 1, and then I could just say that this is going to be u to the 100. Can we find the derivative of that? Yeah, what would be the derivative of that? Okay, so that would be 100 u to the 99th, right? So that's just the derivative of the outside portion, okay? Now, what's the derivative of the inside? The derivative of just what's on the inside here. Okay, the derivative of this would be what? 3x squared minus 4, right? So now let's go back and actually put it back together. Okay, so I treated, so there's the outside, there's the inside. Okay, so I'm going to go back, and I already know it's supposed to be, so I'm going to turn it, so it's going to be 100, but instead of putting u, I'm going to put it what it actually is. So it's going to be x cubed minus 4x plus 1, right, to the 99th, times the derivative of the inside. What do we say the derivative of the inside is right here? So it's my 3x squared, right? Okay, so it's a 3x squared minus 4. And that's it. So just derivative of the inside times the derivative of the outside. Does that make sense? It's not that bad, right? Okay, let's look at the second one. What is the derivative of the inside first? Just 3, right? Because pi over 4 is a number. That's a constant. It's no variable, right? So I'm just going to be doing this one. So derivative of this is 3. So it's going to be 3 times... Now, what did we say the derivative of cosine is? Negative sine, right? So it is negative sine. So it's going to be times negative sine, right? Do I change the inside, though? Do I change the inside? Do I change the inside? No. I am not going to change the inside. Just like I did up here. I didn't change the inside, right? So this is going to be sine, negative sine of 3x minus pi over 4. And the only thing I would do to clean that up is turn that into what? Negative 3, right? So that's going to be a negative 3 sine of 3x minus pi over 4. You want to grab the 3.1? It's on the shelf. Yeah, it's in there.
Okay.
Are we okay with this? Not too bad, right? So, okay, it's gonna help out a lot, especially on these weird ones. Okay, so let's start with what's in this case. This is going to be my inside portion here, so it's going to have two parts to it here. So what's the derivative of that right there that I put parentheses around? Just 2x, right? So it's going to give me 2x times, what's the derivative of e to the x? Just e to the x. But in this case, my x is just all this, isn't it? So the outside was the e, the inside is all of that. So it's just going to be e to the, do I change any of that? No. No, so I get x squared minus 4. How about this next one? Sine 4e to the x. So, what's the derivative of the inside? 4e to the x, right? Because it's not going to change it, right? Huh? Yeah, nothing to do, right? Because e to the x is just e to the x, and there's a 4 there, right? So it's going to give me 4e to the x times, what is the derivative of sine?
Negative cosine?
No, not negative cosine, just positive cosine, right? So if you guys remember the circle, so it's going to be positive sine, cosine, and negative cosine, and it goes this way for derivatives. So it goes clockwise for derivatives. Okay, so we're going to have a positive cosine, and what's going to be on the inside? Just all of this, right? I'm not changing that. So it's going to be 4e to the x. All right, and so this one goes along with my trigs that we did the last section, I think it was. All right, so the derivative of tangent. Now, remember when those I gave you those little flashcard packets, the note things, those flashcards? You could actually test yourself on these things. So by the time we get to the end of the semester, you should know these by rote. I could tell you, hey, what's the derivative of tangent? And you would say? Secant squared, okay? So whenever we're doing these, you should be able to get to that point. So patterns over and over again. Like I said, that's why I gave you the flashcards, so you can get through all this. All right. Find the equation of the tangent line to the graph of y equals 5 e to the 4x at the point 0, 5. So we're finding an equation of the tangent line. Okay, so now, first, what's the first thing I need to do? Find the derivative. Now, what is the derivative going to give me? The slope, right? The derivative is going to give me the slope. Okay? At what point?
0.
At point 0, because the x value here is 0, isn't it? So it's going to give me the slope at the point 0. Okay? So we're going to go through and do that. So it's going to be y prime is going to be equal to, now, right here on this one. Okay, chain rule. So now, what's this right here? So it's going to be what? Just 4, right? So it's 4 times this right here. So it's going to give me 20, right? 20. Now, what about derivative of the e? It's e to the 4x, right?
That's it?
Yeah.
It's how easy.
Yeah, but like it
Uh-huh.
looks different from the rule which we
Why?
showed us. Like what is the G and what
Okay, in this case, my inside is this,
It's G.
and the outside is E. Does that make sense? So if we go back a couple pages, like this. So my outside was like the U here, right? The outside would be U, so that in the terms it would be basically e to the 100, right? So that's what I'm actually referring to this as. So like this, so it would be to the 100, so I'd have to take the derivative of that, which would give me the 100 outside, right? And then it's going to be times e, but because e, the derivative of just e to the x is always e to the x, so it doesn't look the same. Okay, all these other ones actually look the same. So this is going to be f, so this is going to be f of g of x. So it's going to be f prime of g of x. So that's going to be the derivative of the outside without changing the inside. Okay, does that make sense? So it's the derivative of the outside without changing the inside times the derivative of the inside, which was g prime of x. So that's the derivative of the inside, which we got here, right? That's going to be my 3. Yes? That's the 3 from there. And then it's going to be derivative of the outside. And in this case, my outside was the cosine, right? That outside is cosine, so I took the derivative cosine, which gave me sine, but I didn't change the inside, did I? No, I didn't change that. All right, does that make more sense, or no?
Yeah, like, I mean, well, can you turn to that one which we're doing now? I mean, don't we need to multiply, like, on e of 4x one more time?
Yeah.
Because we didn't get just the g prime.
Okay, so now, what's the derivative? Okay, what's the derivative of this?
Yeah, like,
4 times, right?
Yeah.
Now, what's the derivative of 5 e to the x?
5. Yeah.
Times 5 e to the x, right?
Okay.
But in this case, it's going to be 4, right? Okay? Because this is my g right here. This is the g. It doesn't change for this one. When I did the derivative of the e to the x part, I don't change that. Because this is the g and that's the f prime. Because the derivative of e to the x is just e to the x. So it's not changing as drastically. Okay, it's just basically, it is what it is. Does that make sense?
Yeah.
Okay, yeah, e's are the weird ones. Okay, so now we get that point right there. So now we have the derivative, right? So now I have to plug in 0. So if I plug in 0, what is 4 times 0? 0. What is the anything to the 0 power? 1 times 20? Okay, so I know that the slope is going to be 20, right? Yeah? The slope is going to be 20. So my formula, y minus y1 equals m quantity x minus x1. So I'm going to have y minus, what is my y1 in this case?
5. Oh, wait.
20.
5.
It's 5, remember? Remember, here's my points. So it's going to be 5, right? Equals m. We said m is the 20. Quantity x minus, what is the x? 0. So I'm going to come up with y minus 5 equals 20x, right? Plus 5 to both sides. So y equals 20x plus 5.
That's the equation of the tangent.
That's the equation of the tangent line of that function at that point. And for the sake of, that's where I'll stop in the notes off today. So it's 5e to the 4x. Let's see. All right, documents. So 5e 4x. Okay, and then my tangent line. So what was my tangent line?
0.
Y.
So it's 20x, right?
Find the x
X
minus
plus 5.
plus 5.
There you go. So if I zoom in, so it's touching it at the point right here at 0. So this is my tangent line. The red is my tangent line here. So it's a really steep slope right here, isn't it? So yeah, so right here, it's going to be 0, 5. I think that's what that is right there. And so that's just the equation of the tangent line for that one. Does that make sense? It works, right? Okay, it's touching it at that single point right there. All right. So don't forget, like and subscribe.